Number 44, a beautiful problem where we combine conservation of energy and projectile motion. So let's look at what we have. Initial, it starts from rest, frictionless, conservation of energy. So we have UG to begin with. And technically, I could say that right here, I got UG still plus kinetic energy. Nothing's stopping me from saying that this is my zero level for UG. And then I can just say UG equals K. UG initial equals K final. And then just MGH initial and call my H initial at 25 minus 3, 22 meters. That's my original height compared to the level where my skier exits the ramp. Another thing that is very important for you to realize is when his velocity is right here, it is directed at 30 degrees because that's a 90 degree here. So if that's a 60, that's a 30. And from there, it's all just MGH initial equals MV final squared over 2. Mass cancel. Double that, so V final is going to be a root up to GH initial. So V final is going to be 19.6 times 22. Gets me 20.8, if I round it correctly, 20.8 meters per second. Then from here, I have 3 meters is my height. So my projectile is going to travel like that. Change in Y for my projectile is -3 meters, and then V initial Y is 20.8 sine of 30 degrees, because that right here is 30, so 10.4 meters per second. All right, so then I'm solving for -3 equals 10.4 time minus 4.9 times squared. That comes from my equation y equals v initial t plus 1/2 acceleration t squared. That's the classical equation. Since this is free fall, we call that a g, so that becomes -9.8 over 2. It's -4.9. Then when you graph this as -4.9 t squared plus 10.4 t plus 3 equals 0, and since we're graphing for time, negative is not going to work for us. We're looking at 2.38 for seconds, so time equals 2.38 seconds, and then my change in x, which is ultimately what I'm looking for, is going to be, because the question is how far horizontally is her touchdown point, so it's going to be 20.8 cosine of 30, because that's the horizontal velocity, times 2.38. So that gets me 43 meters is our answer.